Hello everyone. In this video we will try to solve a new exciting coding problem from Codeforces. The title of the problem is Dice Tower. Before solving this problem I would like to say this to you. On Codeforces there are certain problems which have very easy solutions. The solutions are pretty easy, but the only challenge is to understand the problem statement. That's the only challenge. Once you are successful in understanding the problem statement, then solving it becomes a very simple job. This is one such kind of a problem where understanding the problem statement is very much difficult. Not difficult, but a bit challenging, you can say. Yeah. But once you understand the problem statement, once you understand what the question is asking from you, and once you understand to imagine it or to visualize it, then solving the problem becomes very much easy. Visualization is very much required to solve this problem. I will try my best to explain everything properly. I will also help you to make the visualization in your mind, but I don't know whether I will be 100% successful in explaining things to you, because this problem requires you to visualize a die, and a die is a 3D object, and obviously I cannot show you a 3D object on a 2D screen, but I'll try my best to do that. And yes, you will also have to bear with me, you will have to adjust, you will have to open your mind and think and imagine things, and only then you will be able to understand it properly. So yeah, it's not that very difficult, but we will try our best, right? Yes. So this is the problem statement, but before we get into the problem statement, let me zoom it a bit so that everything is properly visible. So we have a person in this problem, and his name is Bob, and Bob is playing with a six-sided dice. Okay, Bob is playing with six-sided dice, and this is how it looks like, when you unwrap it, when you unfold it, this is how it would look. So this is the image. You can see this is the image of a die when it is unwrapped or unfolded. Okay, so if you fold it, then it becomes a cube. It takes the form of a empty box, okay, having six sides. That is how it looks when you fold it, but this is its unfolded image right in front of you. Okay, and what Bob is trying to do is Bob wants to build a tower of all these dice. He wants to build a tower, so he's stacking them one upon another. He's stacking these dice and keeping them one on top of the other, and he's building a tower. And what Bob wants us is to find out whether the number which Bob will give us, those many number of points will be visible on the dice or not. Again, this doesn't explain anything. Let me go slowly. So Bob will give us a number, a random number. Okay, the number could be anything between 1 and 10 raised to power 18, as you can see. So yeah, Bob will give us this number, and we have to tell whether those many pips are nothing but these points. You can see these dots at the surface, or at the side of each at each side of a die. You will find these points, right? This is 1, this is 6, sorry, this is 5, 4, and so on. So these are pips. We call them pips, at least in this question. Yeah, so these are the dots or the pips. So the number of the pips that are visible has to be, or whether it is possible to have these many pips, which Bob is asking us. So Bob will give us a number, let's say 37. If Bob gives us the number 37, then we have to tell whether it is possible to have a tower of dice which could contain, not contain, but a tower of dice which on which uh, 30, what was the number, 38, right? Yeah. So is it possible to have 38 number of pips visible on, you know, if we build a tower of a die, a tower of dice? Yeah. It's I'm struggling to explain the very problem statement. I don't know what's going to happen when I'll explain the solution, but yes, I'll try my best. And yes, hopefully you got the point, right? So whether it is possible, obviously this is not gonna be very easy to explain, but yeah, if the number that Bob is giving to us, if that many number of pips are visible, will be visible if we stack these dice on top of each other, whether it's possible or not, that we have to tell. So our reply will only be in a yes or no. We only have to reply yes or no. We will say yes if it is possible to have those many dice visible if we stack them up, and we will say no if it is not possible to visualize or to make that number visible, uh, you know when we stack these dice. For example, okay, for example, let's say this is a die. Don't know for what reason. Okay, that's okay. And I'm just gonna copy paste a couple of times, and I'm gonna keep them on top of each other. Select this one, and I'm gonna keep it on top of this. Yes, this is our stack of die, or a tower of dice, as we can call them. Yeah, so if we get a number, let's say 38, is it possible to build a stack with 38? That we have to find out. We have to say whether it's possible, yes or no. That we have to say, right? Whether it is possible to visualize 38 dice when we stack them, not 38 dice, my bad, 38 points on the sides of the dice, whether it is possible for us to make 38 points or 38 pips visible when we stack these dice, or if it is not possible, we have to say yes or no. That's the thing. And 38 is not the only number. The number could be anything. It could be 48, it could be 58, it could be anything. Okay, I hope you got the point. Let me decrease the thickness. Yeah, now it looks great. So before solving the problem, we will first understand some basic things. Okay, so let me draw a surface. It's okay. Yeah, this is it. So a die will be kept on a surface, right? This is the die. Okay, I can just paste it. Yeah, this is the die. So it's kept on the surface. So when a die is kept on a surface, then one side will be touching the surface, right? One side of the die will touch the surface. That's why the pips that are there present on that side will not be visible. And those pips that are not visible, we cannot count them. That's what we are said. You know, yeah, we don't have to consider the ones that are not visible. The number of visible pips is exactly xi. So only the visible pips we have to consider. So obviously when a die is kept on a surface, obviously a die will be kept on a surface. The tower that we are building will be kept on a surface. It's not going to hang around in the air. So if we keep it on the surface, then one side will touch the surface, and the pips that are present on that side will not be visible. So in total we have 21 pips on one die. So when this die is kept on a surface, one side of that die will not be visible, and we know that in total one die will have 26 pips. Sorry, not 26, 21 pips. 21 pips will be there on one die. We can calculate that. There are 6 sides, and each side has 1 2 3 4 5 6 no, 1 2 3 4 5 6 and so on. So we can just add that 1 plus 2 plus 3 plus 4 plus 5 and plus 6. We just have to add it. So 6 plus 4 gives us 10, then this will become 15, and this will be 5. So 15 plus 5 will give us 20, and this is 1. So that turns out to be 21, right? So 21 pips are there on one die. Total 21 pips are there. So if the side that touches the floor is the side that has 1 pip, then 21 minus 1, 20 pips will be visible, right? Hopefully you are getting the point. If the side that touches the surface contains 1 pip, then 21 minus 1, 20 pip will be visible. What if instead of 1, 6 pips, the side that contains 6 pips is touching the surface? If the side that contains 6 pips touches the surface, then obviously 21 minus 6, 15 pips will be visible. We need to remember that this die can be rotated and kept in any way. So if we keep the side which has 5 pips facing to the ground, then 16 pips will be visible. If we keep the side with 4 pips facing downwards, then 17 pips will be visible. If we keep the side that has 3 pips facing downwards, then 18 pips will be visible. If we keep the side that has 2 pips on it, and if we keep it in a way that it faces the downwards, it touches the surface, then obviously 19 pips will be visible. And if we keep the side that has 1 pip touching the surface, then only 20 pips will be visible. So from 20 to 15 we could have these many pips visible on one die. So whenever we will have one die, these many possibilities are there. These are all the possibilities that we can have, okay? If we have one die kept on a surface, if this is the scenario, if this is the scenario where one die is kept on a surface, obviously it's gonna be kept on a surface. It's not gonna hang around in the air. It's gonna be kept on a surface. So if there is just one die, then these are all the possibilities. Okay, let's look at another scenario. In this scenario, a die is sandwiched. What do I mean by sandwiched? When I say sandwiched, means a die is between two other objects. Here we go. In this image, this one, we can say that it is sandwiched. It is sandwiched. It is sandwiched between, I will just say sand. It is sandwiched between the first die and the third die. The second die is sandwiched between the first die and the third die. Sandwiched in the sense it is between the two. The one is there on the top and the other is there in the bottom, so it is in the middle of these two. So that's why it is sandwiched, we can say. But is that the only die that is sandwiched? No. we know always that the tower will not be hanging around in the air, so obviously the first die is also touching the ground. It is there, it is kept on a surface. So if it is kept on a surface, then obviously this one is also sandwiched. So two dies are sandwiched, the first one and the second one. These two are sandwiched, and this one is not sandwiched because it is open from the top side. So it's not sandwiched, it is just kept on the second one. So the thing we know about a sandwiched die is a sandwiched die will necessarily always, no matter how no matter what is the orientation of that die, if it is a sandwiched die, then it will necessarily always have 14 pips visible. It will have 14 pips visible, 14 visible pips. How? Let's verify that. This is the die, okay? If I keep the side that has 6 pips facing or touching the surface, then obviously opposite to this face is there, the face that has 1 pip. So 1 pip will be facing upwards and 6 pips will be facing downwards. So total 7 pips will not be visible. So there are total 21 pips in a die. We have already counted that at the top, right? So 21 minus 7 will give us 14. So that's why 14 pips will be visible. We can rotate it in a different way. Suppose if 5 pips are facing downwards, so opposite to 5 it is 2, so 2 pips will face upwards. So 5 pips are facing downwards, 2 pips are facing upwards, so 5 plus 2 gives us 7, so 7 pips will not be visible. 21 minus 7 gives us again 14. So no matter how you rotate the die, always 14 pips will not be visible. 7 pips will not be visible, and only 14 pips will be visible. If I let's say 4, so if the side having 4 pips is facing the surface, is facing downwards, then obviously opposite to that is the face with 3 dice. So 3 will be facing the topwards and 4 will be facing downwards. So 3 plus 4 gives us 7 again. So 7 will not be visible. 7 pips will not be visible, and 21 minus 7 gives us 14 again. So 14 pips will be visible again. So from this we can understand that no matter how you rotate a die, whatever could be the orientation of a die, only and only 14 pips are visible if the die is sandwiched, right? So if the die is not sandwiched and if it is kept open, then these many possibilities are there. It can have 15 pips, it can have 16, 17, 18, 19 and 20. These many possibilities are there if a die is kept on a surface. But if a die is sandwiched between something, maybe anything, if it is sandwiched, then there is only and only one possibility, that it will have 14 pips visible. Only and only 14 pips visible, no matter how you rotate it, no matter how you keep it. Only and only 14 pips will be visible if it is sandwiched. We need to remember these two things, right? If that is clear, then let's get to the problem that we have. So we need to understand that if we get a number, we will get a number in the input. Bob will give us a number and we have to tell whether it is possible to arrange a tower of dice in which these many pips will be visible. So if Bob gives us 7, so we have to create a tower of dice where 7 pips will be visible. So we have to say whether it is possible to build that kind of a tower, to have that many number of pips visible or not. We just have to say yes or no whether it is possible or not. Hopefully you got the point, right? So the number could be anything from the range of 1 to this 10 raised to power. So it's a very long number. So if Bob gives us a number 2, let's say if Bob gives us a number 2, then obviously we know if a die is kept on a surface, only these many possibilities are there, only these many pips will be visible. So 2 is not possible. If Bob gives us a number 2, and even Bob can give us 1. So if Bob gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, nothing will be possible, because even if you keep one die, it will at least give us 15 pips, not less than that. We cannot have less than 15 pips visible. We cannot make that possible, because one die contains 21 pips, and even if we rotate the die so that the maximum pips are facing downwards, are not visible, still we will have 15 pips visible. So that's why 1 to 14 is not at all possible. So that's our first case. That's our first edge case, that if, that is our first edge case. If x turns out to be less than or equals to less than, I can say 15. If x turns out to be less than 15, then the result will be no. The answer will be no. If x is less than 15, then obviously it's gonna be a big no. Okay, this is the thing that we understand. Now let me just clear everything. I'll reset the canvas. Yes. Now when I've reset the canvas, I'll also have to decrease the stroke. Yeah, now it's all great. Can I paste? Yeah, still I can paste these. So yeah, so now the first condition is done, that if Bob gives us a number less than 15, then we will straight away say no, because it is not possible. Even if we have one die, still it is not possible, because one die will either give us 15, 16, 17, 18, 19 or 20. It cannot give us 21 also, because one side has to touch the surface. So even though there are 21 pips in one die, still its one side will touch the ground, and that's why its one side will not be visible, and that's why it could have 15 to 20. It will not be able to give us 21 also. So that's the reality that we have in front of us. With that reality, we will try to solve the problem. We also understood that a sandwiched die will necessarily give us 14 visible pips. We know that. So let's understand the problem. But to understand the problem, we will straight away take some examples from the given examples. So we have 29 with us. So let's say 29 is the number that is given to us by Bob. So how to check whether it is possible to keep 29 or not? So let's say this dice can have max to max 20 pips visible. So it's not possible with this one. So what we will do, so this die will have max to max 20 pips visible. So it's not possible for this die alone to give us 29 pips, right? So we will have to add another one. So I'll copy, I'll paste. So another one. So now after having another one, this die is not sandwiched, but this die is sandwiched. This die is now sandwiched, and we know that a sandwiched die will necessarily contain 14 pips. It will show 14 pips. 14 pips will be visible from a sandwiched die. And this die, since it is not sandwiched but it is kept on a surface, it can again give us 15 to 20, any number between 15 to 20, including 15 and 20. This die can give us based on our requirements. we can make it give us anything. So this is giving us 14, but we need 29. So how much more we need? So we'll say 29 minus 14. 9 minus 4 gives us 5, and 2 minus 1 gives us 15. We need 15. So can this die give us 15? Yes, it can give us 15 because it is not sandwiched, and a non-sandwiched die which is kept on a surface can give us 15 to 20. So yes, the answer has to be yes. This is our answer. Let's check. Yes, the answer says yes. Let's take another one. This time let's take 38. I'm not gonna waste much time, so let's try to get into that. So the number that's given to us is 38. 38. 38. So how many sandwiched dies we will require? For that, what we can do is we can take modulus. What we can do is we can take modulus. Now we are getting into the solution part. Okay, so pay attention and stay focused. So what we will be doing is we will take 38 modulos 14. What will we get by doing this? By doing this, we will be getting, first we need to understand what we will get by doing this. By doing this, we will get something very interesting. We cannot reach out to this number using just sandwiched die. That's not possible. Why? I'll get to that as well. Okay, let me explain that now itself. So if this is the tower, then obviously a tower will not only and only contain all sandwiched dies. It's not possible for a tower to contain only and only sandwiched dies. One die in a tower will necessarily be a non-sandwiched one, the top one. The top die will be a non-sandwiched die. So here is our calculator. So 38 modulo 14 gives us 10. So from here we can understand that the last number that was divisible by 14 was 38 minus 10, because we got 10. Yeah. So 38 minus 10 gives us the number, the last number, which was fully divisible by 14 without giving any decimals, without giving any remainders, and that turns out to be 28. So 28 is, wait a second, 28, we know it is going by 2. So yeah, 14 into 2 gives us 28, and that is the number that is fully divisible by 14 and is closest to 38, because 14 into 3 will give us a number which will be bigger than 38. It's giving us 42, and we cannot take 42 because it's bigger than 38. We want a number which is closest to 38 but has to be less than 38 and has to be divisible by 14. Yeah, so that turns out to be 28. So the difference between 38 and 28, that is what the modulo will give us. Now the modulo will give us the difference between the number that was divisible by 14, the closest to 38, and the difference between that number and 38. That we will be getting from the modulo operator, the modulus. So 38 is 10 is the result that we get. So over here, this one will have 14 14 pips visible because it is sandwiched. The die that is sandwiched will necessarily have only and only 14. This one will have 14. So 14 plus 14 gives us 28, right? So now we need more 10. This gives us 10. So we need more 10 pips so that we can get 38. We need more 10 pips. But now the only thing we can have is one dice which is not sandwiched but is kept on the surface. And we know the possibilities of pips on a, okay, that I have erased. The possibility of pips that can be visible from a dice which is kept on the surface is from 15 to 20. So this die can give us any number between 15 to 20, including 15 and 20. And we want the number 10. We want the number 10. If we will remove this die, we will get 28 total pips. We will get not 28 also, we will get more than 28, right? Yeah, we will get more than 28. How much we will get? Because if we remove this, then the second one no longer remains sandwiched. It will become open. So it will contain from 15 to 20. It can contain any, and we want 38. So 14 we already have, right? And now how many more we want? This turns out to be 4, this turns out to be 2. We want 24. We want 24 more pips, but if we remove this, this one can only give us 15 to 20. It cannot give us 24, but we need 24. So even this will not satisfy our requirement. Removing a die is not satisfying our requirement. Rotating is not satisfying our requirement. Adding another die is also not satisfying our requirement. So that's why 38 is not at all possible. So we will return no. So we will return no. Yeah. So how did we compute this? How to calculate all of this? So what we can do is, when we say 38 ampersand, sorry, not ampersand, percentage 14, that is a modulo symbol, we get 10, right? So what we will say is, our conditions will look like this. If this, the result of this turns out to be 10, then obviously we will say no. Then what it has to turn out? Let's check with something that works. 34 works. You know, the answer for 34 is yes. So let's check with 34. So if we take 34 modulo 14, what will it give us? Let's check. 34 modulo 14, it gives us 6. And it works. How it works? This one will give us 14, right? So 34 minus 14, how much? 0, 3, 20. Yeah. So we just need 20, and we can get 20. We will not be having this one in that case. We will not have this one. So this one can be removed, and this one can give us 20. How it can give us 20? It can give us 20 if the side having one pip will face the bottom, then it will give us 20. So this will give us 20, and both of them combined will give us 34. So how did we compute this? We got 6, right? 6. So what we will be doing is, the moment we get 6, we will say that it is possible. But let's take another example. Let's take, for example, 33. Is it possible to have 33 number of pips visible? Is it possible? Let's take that. Now what will it give us? We all know it will give us 5. But is it possible? I guess yes, it is possible, because this will give us 14, and 33 minus 14, how many more will we need? Will be needing this. So this will give us 9, and this gives us 19. And yes, we can remove this die, and from this die we can get 19 pips visible. How we can get 19 pips visible? We can keep the side that contains 3 pips touching the surface. So 21 minus 3, no, not 3, 2 will give us 19, right? So the side which has 2 pips, we will keep it facing the surface, and that's how we will get 19 pips visible in this die, right? So that's how we will be working over here. So from here we can understand that if 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 the result of the modulo turns out to be less than, if the result, this is x which is given to us by Bob, if the result of this turns out to be less than or equals to 6, then we are able to build a tower. Then we are able to build a tower. But if it exceeds 6, like for example, if we had 35 as an example, 35 modulo 14 will give us what? It will give us 7. So let's check whether it is possible. This will give us 14. So 35 minus 14, 35 minus 14 gives me 1, gives me 21. So 21 is needed, but we know this one will only give us 20 to 15. Sorry, 15 to 20. Yeah, 15 to 20. 21 is not possible. Even if we add another one, the number of pips will increase and it's not gonna remain 20. It's gonna increase not exponentially, but it's gonna increase a lot. So it's not possible to get 21 pips. So from this we get the idea that the answer for this has to remain less than 6. But the explanation still remains incomplete, right? It remains incomplete. Why is it that a number less than 6 turns out to be working? It is because of the modulo. What the modulo is giving us is the difference. It's the difference between something that is divisible by x and the number that we have, and the number x itself. It is giving us the difference. And if that difference is less than 6, if the difference is less than 6, then obviously this, let's say, is, these are the dies, and if this one is giving us very high value, okay, very high value, and this one, this is not the only one, this is how the structure is, and this one is giving us a very high value, and this one somehow gives us a very low value because it has only 14. So if we remove this one, then the chances are that we can get 1 extra or 2 extra or 3 extra or 4 extra or 5 extra or 6 extra. We can get 6 extra numbers from this die if we remove the top one. We can get 6 extra number. Why? Because this die will not remain sandwiched die. The moment the top die gets removed, this die will not remain a sandwiched die anymore. It will not remain a sandwiched die anymore, and since it will not remain a sandwiched die, it can give us any of these possibilities. So if we need 6, then we can remove this one, and we can rotate this one so that it gives us 6. It already is giving us 14, right? So 14 plus 6 will give us what? 20? No, not 20. 14 plus 6, it's gonna give us 20. It's gonna give us 20. So 20 is obviously possible for a die that is at the top which touches the surface. So this is what it will give us. So anything that is 1, 2, 3, 4, 5 or 6 we get as the difference, then obviously it works. But yes, another catch is there. This x modulo 14 should not be equal to 0, because if it turns out to be equal to 0, then it means that it means that if 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 it turns out to be 0, then it means that our tower will only and only consist all sandwiched dies. Every die in the tower should be a sandwiched die, which is impossible, because if we have a tower, then obviously the topmost die will remain unsandwiched. It will not be sandwiched. It will remain free from the top. So that's why it is impossible to have a tower which just contains sandwiched dies. It is impossible. That's why we have to check the condition that x modulo 14 doesn't turn out to be 0. We have to check this one also. So we will write the code directly right now. Yeah, so what I'll do is I'll open this in a new tab. Yeah, and obviously we have Java as our language, and the thing we will require is scanner. So I'll say import. Wait a second, let me zoom it. Yeah, now it's visible. This much is better. Yeah, import java.util.scanner. We will have a public class, and the name of that class will be solution, as always, because we are creating a solution to the problem. We are getting a solution. So public static void main, as usual, public static void main string args. Here we will have scanner object, new scanner system.in. Whenever I type fast, I do a lot of typos, so I'm expecting that we will get typos, but let's hope we don't get any typos. So after declaring the object, we will simply say sc.close, because we don't want to forget that. Last time we forgot that. Int t equals sc.nextInt. What is t? T is the number of test cases. T is the number of test cases. So first we have to take input t, number of test cases. Here the number was 4, but that could be anything. So first we have to take t, integer t, as our input, which represents the number of test cases. Then we have to iterate over t. We have to take the output t times, and we have to give the we have to take the input t times, and we have to give the output t number of times, because we have t number of test cases. So that's why we will use our favorite for loop for that. We'll say int I equals 0, I has to be less than t, and I will be plus plus. That means I will increment each time, and in this we will take one input, that is x. X is the number that Bob gives to us. So we will say sc.nextInt. Yeah, and now the first condition that we checked was if the die is kept on a surface. I'll draw it again. If this is the surface, if the die is kept on a surface, if this is a die and it is kept on the surface, then obviously one side of the die will touch the surface. That's why that side will not be visible, and that's why the total number of pips are 21 in a die, but out of the 21, one side will not be visible. If the side that is not visible is containing 1 pip, then obviously 20 pips will be visible, or if it is 2 pips that are touching the surface, then 19 pips will be visible. And likewise, if 6 pips are touching the surface, then only 15 pips will be visible, 16, 17 and 18. We have these many possibilities, right? So if we get a number that is 14, if x turns out to be 14, then it's not possible to represent and to put 14 or to keep 14 pips visible. It's not possible to keep 14 number of pips visible. Why? Because even if we put one die, that one die will either give us these many numbers. Even if we try to rotate it, the minimum number that it can give us is 14. So anything that is less than 15 is not possible. So we will say if x is less than or equals to 14, let me write it properly. Yeah, if x is less than or equal to 14, then we will simply say system dot out dot print ln. Yeah, last time that ln gave us a big problem. Yeah, system dot out dot print ln, and we will say no. Yeah, and then in the else condition comes our main part. What we will do? Else we will simply take modulus x modulo 14. Sorry, let me just close this one. We will say x modulo 14, and we will store it inside. Yeah, another thing that I forgot to mention is this x is a very long number. It extends up to 10 raised to power 18. So we cannot, it cannot be stored inside int. So that's why we will take long over here. Now this is the thing that I forgot to mention, but I suddenly realized it. So yeah, it's good that I realized it. So we will be storing it inside long. So this will also be long modulus equals x modulo 14. Can write it like this also. So x modulo 14. Then x modulus 14 we have. Then we have to check this condition whether this modulus is less than or equals to 6. This modulus is less than or equals to 6. We have to check, and also we have to check whether this modulus is not equals to 0, because if turns out to be 0, then it means that there has to be only and only sandwiched dice inside our tower, which is impossible, because if there is a tower, then the topmost die will not be sandwiched. It will be open from the top side, from the top position it will be open. That's how we will have a tower. Otherwise the tower will be infinite. If you are asking us to have all the dice to be sandwiched, then the tower will never end. So it's not possible. So that's why we will say and modulus should not be visible, should not be equals to 0. Yeah, it needs to be less than or equals to 6, and it need not be equal to 0. And then we will say system, what is this? Codeforces context. Okay, system dot out dot print ln. We don't need to forget ln. We will say yes. So if modulus is less than or equals to 6 and modulus is not equals to 0, then we will return system dot out dot print ln yes, or else we will say system dot out dot print ln no. Yes, this is it. Yeah, this is it. This is the code. You can see how short the code is. The solution is very short. But yes, the explanation took so long. I had to explain a lot of things because it required a lot of visualization. So that's why it took time. But anyways, let's check whether our answer is correct or not. Let's submit. Let's wait for some time. Yeah, here you can see the verdict. What is it showing now? Yeah, it is something related to int, next int. Yeah, so the problem that we had in the previous output was we said long x equals to sc dot next int. Instead of this, we had to say long, long, long. Yeah, that's the typo that we did, and that's why we were getting that error. And this time we will not get that error. Yeah, submit. It is in queue, we can see. Let's wait for some time. Yeah, it is now accepted. So yeah, that is it. It was a very easy problem. The solution was very easy actually, but the problem statement was so confusing and it was so hard to visualize it. But yes, I tried my best to explain it. Hopefully you got it. And it was a bit messy, I know, and I totally understand that it's not easy to visualize this kind of a thing and to understand it to its fullest, but I tried my best, and hopefully you also tried to get some kind of an idea and you understood how modulus works and how the difference is calculated and all of it. So yeah, this was it. Thanks for watching the video, and yeah, thanks for watching. Yeah, bye.